Hello there, everyone. Right, today we are meeting with a new topic. We want now to focus on mechanical drawing. Some would call it machine drawing. Right, but today's lesson is on mechanical analytical. So we want to look at how we approach this question. It's a very important question in paper 2. That is question 1. So we want to look at ways of looking at this. Remember, at some point we looked at civil analytical, right? And this question carries 30 marks out of 200. And relatively, if you approach it well, you'd find that you would get a lot of marks, right? And it's meant to make sure that no one would get a 0 in an exam. I'm not saying that any one of you would get a 0, but it's a very important question to kickstart your exam. Right, like I said, it's part of the bigger picture with regards to mechanical drawing, right? And is the analytical question. So we have got 2 revision tasks that we want to look at today, right? Earlier on, I said it's question 1 of paper 2, right? So we want to look at ways of responding to this and where to get the answers and how to present those answers on the paper that is given. Like always, right, our business is not to talk a lot, it's about doing a lot. So we want to make sure that we focus on doing something in order to make us understand. So let's get straight to it and enjoy the lesson. Right, if you check, you'd find that in most cases, the information with regards to this question, it would be basically the same, right? You would find question number 1, paper 2, right? The front view and top view of a micrometer, right? The sections, the parts list, a title block, a table of questions, the drawing. The drawing has not been prepared to the indicated scale, right? So when it is not drawn to the indicated scale, we normally write NTS, right? NTS standing for not to scale, right? Instructions: complete the table below by neatly answering the questions which refer to the accompanying drawing, title block, and the mechanical content. So you'd find in terms of the analytical, here is the table of questions, and that's where we are going to provide our answers, right? And you'd find there's also information regarding that particular question. So we have got this, like we are told, it's a micrometer. We are going to use information based on this micrometer. The beauty of this question is that all the answers that you require, let me put it at, say, 98% of the answers that would require, you would find them here, right? So you need to use your understanding of machine drawing, understanding of analytical drawing, understanding of engineering components and how they are utilized in the world of industry, right? So you have got the information, like we said, and you also have got what we refer to as the parts list, right? Remember, in our assembly drawing, when we are talking about a parts list, we are talking about the parts which would make up that assembly. So you have got a number of parts which are just thrown around, and they are meant to be assembled or put together, right? But there is also a table which is created in order to illustrate the description of each part, like you have here, that's part, you have got the description of that part, you have got the quantity. In some cases, you'll find that it is referred to as number of, right? Then you have got the material that has been used, right? This is the description of the material that has been used. So we would need to look at all this in order to answer the question. So boys and girls, I urge you to make sure that you don't skip this question. The first question that you would need to look at in terms of answering the exam or responding to the exam paper, do question number 1. Of course, you go through all the questions, see where you would find it easier to draw or to respond, but do not skip question number 1. Right? It's very important because all the answers are there, right? And you must respond to question number 1. Right? You also have got additional information that would be provided in terms of the diagram that you are going to refer to, right? Such as the drawing program, the scale, dimensions, and so forth. All that information would be provided. So when you come across a question, sometimes it's important to pick out the keyword. Say, for example, when we look at number 1, who prepared the drawing, right? Who prepared the drawing, right? When someone is talking about preparing the drawing, it's just as good as who drew the drawing. Who was the person who was responsible for drawing that particular diagram, okay? So you would also go and check, right? On the title block or the information that is provided, right? Look for the keyword, right? Here we have got drawn, okay? So I'm going to highlight this. This is drawn. So the person who did draw is Wendy, okay? So you would come here now and write in terms of your presentation, like that. Right, I'm using a pen, right? But when you are responding to the exam, I just want to make sure that you are able to see, right, clearly, right? Because this is a broadcast, okay? Right, but when you are writing an exam or you are in an exam setup, you basically make use of a pencil. Do not use a pen, right? It's not allowed. Right, on what date was the drawing checked? So the keyword there, right, it's about checking. So when you go and look for the information, also look for the word checking, right? Here it's checked, right? So if you check, you'll find that it was checked by this pen, right? So that's Jackie, right? And you look at the date, that's 2018-02-10, right? You present the date the way it has been given. So you go back to your space for writing, that's 2018, you would write nicely, 2018 stroke 02 and 10, like that. Right, so it's on the 10th of February 2018. Right, the next question would be, right, in terms of the information that is provided, right, what was Siabongi's responsibility? Right, so you go and look for the name Siabong, right, and you look at this, right? So the responsibility is not the date, it's about this. So it's approved by Siabong, right? Then the responsibility was about approving, okay? Or to approve. As long as you are able to highlight the gist of that statement, right? So it could be approving or to to approve. And double P. Right. Either of the two would suffice. Right. So it's his responsibility was to approve, or his assignment was for approving the drawing. Right. What is the drawing number? Right. So you look again for something to do with drawing number. And that information, like I'm saying, right, would be there. So the issue is looking for something to do with the drawing number. If we come here, you look at that, you would see, oh, there it is, drawing number. So you copy that information the way it is. It's MC dash, not dash, it's MC25 dash V 2018. So far you have got 1, 2, 3, 4, right, without any struggle, right? These are the marks that you have from the top, 1, 2, 3, 4 out of 30, right? So make sure you, when you get your paper in terms of paper 2, right, do not skip question number 1, right? It's meant to benefit each and everyone, okay? Then what material is used to manufacture the anvil? Right, remember earlier on we spoke about the parts list, okay? Right, and we said that the parts list would give you information about the description of the parts and also the quantity of that a particular part, as well as the material that it has to be made from. Right, so if we look at this, you highlight, that is your keyword, right? And the material is here, right? So we'll see that it is tungsten. So you go back and write, you write nicely. Tungsten, like that. Right, how many parts make up the micrometer? Right, if you want anything to do with the parts, right, what is it that we need to look for, and where are we supposed to look for that particular information? It has to be something to do with the parts list. So you go to the parts list, right? Look at how many parts are required to make up that assembly. Remember, we said the quantity. You'll find that in this case, we've got 8 parts, which are supposed to be used for the assembly. But sometimes you'd find that right under frame, you would find, or under outer sleeve, you'd find there are 2 or there are 3 here for the screws and so forth. So all these quantities, they need to be taken into consideration. So if there are 3 screws, right, you do also add them so that you have got the total number of parts. So you are not going only to look at one particular part and say, if there is a screw, there's just one, but how many of those screws are required, right? That will make up the assembly. So in this case, it's 8. So you'd write 8 here. Right, at what temperature will the micrometer be accurate? Right, remember, we are looking at a past exam paper. This is a real paper, right? And it's the 2018 paper. So we are not talking about an exercise. It's a national exam paper, right? And see how easy it is to respond to what is it that you are looking for, right? We have got temperature here. That is the keyword, right? You look for temperature like that, right? Then you come here, look for temperature, okay? Right? Look for the word temperature or something to do with temperature. We have got temperature, will the micrometer be accurate? Right. So we have got here, dimensions are accurate at 20 degrees. This is a reading illustrating temperature and also qualified by accuracy. Okay, so this is the information that we are looking for. So you are going to write 20 degrees. Right, 20 degrees Celsius, like that. Right, what is the maximum size that the micrometer can measure? Right, this is a bit technical. Right, you need to study the information that is given right here. Right, you would find that in terms of the reading, right, so we can talk about this one, right? We have got measurement range minimum to 0.01 and maximum 25 millimeters. So the maximum, right? The maximum size, right? You also come here, you are also talking about the what? The maximum. So the maximum size is 25, right? Right, it is 25, or you can say it's 25.00, okay? Remember, a micrometer is supposed to measure to the smallest and size and very accurately, right? To a fraction of a millimeter, okay? Some to 100th of a what? Of a millimeter. Right, so 25 or 25.00 would be correct. Now, why is the shaft at A drawn as a phantom line, double chain line, right? You would find here, right, if we look at that, right? Now, a phantom line, right, what is it that we refer to as a phantom line? Right, you'll find if we are illustrating, right, the movement of a mechanism, right, we have got a part like this, right? Maybe here we say that is the part. Then we want to show that it can also move to the other side, right? We are not going to draw everything, right? We'll show this one now by way of more like center lines, like that. Now, this is an alternative position this mechanism can assume, right? And it is illustrated by what we refer to as phantom, right? It's not there, but it is a representative, a possible position which can be assumed by a mechanism, right? So if we are looking at that, right, we are talking about the possible position of a shaft, right? But we know that that shaft is not there, okay? Right, so why is the shaft at A shown as a phantom line? So the answer would be, it's not what? Not there. Right, we are simply representing something which is not there. So it's a representation of a detail which is not there. That's what we are talking about. So the phantom line, basically it's about representing information in engineering drawing, right, of certain aspects of machine parts, especially moving parts, right, which may not necessarily be there. So that is a phantom, okay? So the part which is represented is not there. Right, what does the S break at B indicate? Right, we have got at B, right, this is our B, right, we are talking about that part. So what does it represent? Remember, we said that this is not there, but at the same time now, we have got that, right? we know that this is representing or is known as an S break, right? And normally you'd find it represents, right, the information with regards to the size of a shaft. When you are not able to show the shaft size fully, right, you break it, and the break usually is shown by what we refer to as an S. Right, so we are saying that, right, this shaft, right, it has the capacity to be shown in a much bigger size, but because of space limitation, right, you'd find that you have broken it like that. So not the true size of the shaft. So what does the S break at B indicate? Right, it shows that the detail which is given in terms of the size, right, it's not the total size or the full size, is the shortened size, is the reduced size, is the broken size, right? So technically we would say that the shaft not complete. Right. Sorry about that. Right. We would say that the shaft is not complete. Right. So the shaft is not complete. Right. What it means is that you are given the size of the shaft, but in terms of the length, right, it's not complete. It has been shown, right, in a reduced form, just to make you understand that we did not define the full extent of that shaft, right, in terms of length. Right, the length of that particular shaft is not complete, right, or is simply part of the bigger shaft, which is not drawn as a complete shaft like that. Right, then give two uses of chain lines on a mechanical drawing. Right, when we are talking about chain lines, right, one of them, you'll find, if we do this, right, would have described what we refer to as a center line, right? The center line itself, it can be converted. You thicken this end, something like that. Then you do the same thick end, something like that. Then you can label there, This is known as the cutting plane, okay? Right, basically the cutting plane is an extension of a center line with thick ends like that. So two uses of the chain line like that is about the center line, right? It's about the cutting plane. Also, it's about the phantom line, right? Remember, we explained the concept of a phantom line, which we said it is representing information, especially with regards to movement or placement of something which is not there, but which could be in that position as well. Right, so number one, we can talk about center lines. We can also talk about cutting planes. Only that the cutting planes, they need to be defined at the end with those thick ends that I illustrated earlier on. Right, we can also talk about, right, PCDs. Right, that is the pitch, circle, diameter. Right, again, in analytical questions, you may be asked, what does PCD stands for? That's the pitch, circle, diameter. Right, and where would this one be used? Right, if you want to draw a circular center line like that, whereby you will find that you can create a circle there, right? So we can just talk about this one, right? Just by drawing one as a way of dimensioning, you would find that we can say 4 balls or circles, diameter, say 20, right? On 72 PCD, right? What it basically means is that you'd find that it could be diameter 24 circles on 72 PCD. The PCD basically represents this. That's the diameter 72, right? So it's a center line, but which is not linear, which is circular like that. So you'd find that instead of drawing all these circles, right, we'll simply draw one and come up with a dimension not like that, right? So that is the PCD, right? So these are some of the uses with regards to chain lines, right? They basically said two, right? We just needed to explain a bit more. Right, how many surfaces of this micrometer are nailed? All right. What is nailing, right? And where is it used? Right, you would find that we have got this word. Right, okay. Right, basically there are two main forms of nailing that are applicable. Right, we have got what we refer to as straight nailing. Right, straight nailing. Right, and we also have got diamond nailing, like that. Right, let me just talk about or show you, right, if this, right, it's a handle, okay, like this, right, you'll find that you can create these lines, right, and mostly they are for grip, so that you are able to handle something with a bit of grip, okay, right, you can have this, right, so this one is basically the handle, okay, right, so when we create some grooves, okay, right, on the handle like that, this is what we refer to as nailing, okay, right, in some cases you'd find that this could be in form of diamonds like this, right, and when we do this, I'm sure you should be able to see, again, this is some kind of nailing as well, and for creating grip, right, so that you can handle something safely with a bit of grip, so that it doesn't slip in your hands, okay, right, so what the question would be, how many surfaces of this micrometer are nailed, right, and you have got this, which is the same as that, we have got this one also, which is similar to this, you have got that one, which is similar to that, so we have got 1, 2, and 3 surfaces are nailed in order to create a grip for handling purposes. So you would come here and write 3 like that. Right, what is view 1 called? Right, if we look at view 1, remember, paper 2 is in third angle orthographic projection. Whatever question that you would find, you would know that it has been presented in third angle orthographic projection. You don't get first angle orthographic projection in paper 2. First angle is primarily for paper 1. So the moment you have got two views, one on top of each other like this, right? Drawn, you find these views in paper 2. Automatically, you know that the top view is our top view, right? And the bottom view is our front view, right? So we have got top view, we have got the front view, right? If you have got two views, right? If we have got two views like this in paper 2, right, like that, right, and there is a mention that there is a left view, right? So the view that is on the left is your left view, and automatically this one becomes the front view, right? Given two views like this as well, right, and there is mentioned that there is a right view, so automatically this becomes the right view, and this one becomes the front view. So you need to make sure that you understand, right? Given two views, one on top of each other, right, and it's in third angle orthographic projection in paper 2, automatically this is our top view, right, and this is our front view, right? All that needs to be understood, right, in order to appreciate mechanical drawing. So view 1 would be the front view. So you write nicely, front view like that. Keep missing the angle in terms of vision. Right, okay. Then determine the complete dimensions at C, right? You look for C, right? Look for C. Where do we find C? We have got from here to there, right? That is C, right? We are given 16, we are given 46, we are given 19, right? And we are also given this circular part. So what we need to do, right, just to get that size, we need to add 16 plus 46 plus 19 plus, right? If you check, there is a circular part, right? What is the radius from here to there? Is 29. So 29 times 2 would give you 58, okay? Or you can simply say plus 29 plus 29, right? You would get that the distance from here to there, the total distance would be 139, like that. Right, then at D, where is our D? Right, D is here, okay? Right, D is there. Right, this is not so clear. Remember, the D is the reading that we find here in terms of our micrometer. Right, you need to start and check. Right, if we look at this one from 0 to 5, that's 10 and that's 15. Right, and if you check, right, in terms of those graduations, you have got something like this, right? You have got a 0, you have got 1, 2, 3, 4, then you have got 5, 6, 7, 8, 9, then you have got 10, right? 11, 12, 13, 14, 15, you have got 15. But at the bottom, you would see that there is a small dash, like that, like that, like that. And here there is just one that will be able to see in line with the end part of the micrometer reading. So we are going to say this is 0, 5, 10, and 15. So we have got 15 like that. The lower one, if this was, we were reading at the top, that would be 11, 12, 13, 14, 50.5, right? That's what we are having there. But there is also now a fraction of, which is 100th of a millimeter, right? Okay, which is plus that. So we are going to say plus 0.35, okay? Right, so altogether, we are going to have 15.85 in terms of our reading, okay? Right, now it would, of course, benefit those of you who are doing mechanical technology, civil technology, and so forth, because in most cases in the workshop, you are measuring all these, right? Or finer or small details with a micrometer. But at the end of the day, You need to make sure that you study the diagram, get to understand what is it that is required, and also study the sequence and reading of that particular diagram, okay? So the answer that would require here at D is 15.85. Right, 15.85. Then at E, right, where is our E? Right, E is somewhere here, right? Let me just take this one down. Right, that's we have got our point E. Right, and it has been cut like that. Now, we need the distance from here to there. Right, if you go to the other view, you'd find that that distance is clearly shown, okay? Right, we have got the section, right? This is the resultant section of the cutting plane TT, right? And if you check here, you would find that there is a specific measurement that has been given, which is diameter 18, like that. Which is diameter 18, like that. So whatever you do in terms of analytical, look for the information, look for the relevant diagram, and check. In some cases, you'll find that you may need to consider this and that in right. Measure the angle at F, right? We have got F there. What I would urge you to do, right, before you measure that angle, we are looking at this, right? You may need to extend this line, right, like that. Just extend the line and also do the same. Then you take your protractor, right, you align, that is the point. Right, okay. So this is aligned to there, but this at the same time you have aligned this one to there, like that. So you would check that's 10. This is 0, 10, 20, 30, 40, 50, 60, 70, 80, right? Which is here, 81, 82, 83, and 84 degrees, okay? Right. This extension is just to make it easy for you to be able to align with the protractor. So you would come here and write right here, right, that's 84 degrees, like that. Then we take this one up slightly, like this. Right, name the type of section at G, right? The type of section at G, but you look for G, you have got this one, okay? Take this one so we'll be able to see, but we are talking about the part of the drawing with the rest of stuff not in section, but with section. So it has been turned around in order to see the thickness of that particular part. So it's a revolved section. We are talking about the thickness of this. We are also talking about the thickness of that part as well as that in terms of detail, right? So to come here and write nicely, revolved section, right? In an exam, there is no need for you to write section again since the type of section is being sought. So you just write revolved. Remember, you don't have time in an exam. 3 hours is not much. So you need to make sure that you are able to answer as much or move as much as fast as you can in terms of answering all the questions that are being asked. Right. Name the type of section H. Right. You look for at G, that was key. We also look at H now. Right. What is the type of section? Right. There are quite a number of terms that we can use to describe that kind of section. It can be referred to as party section, right? Like this. Party section, right? Or it can also be referred to as scrape section, right? It can also be referred to as localized section, but one which is used mostly is part section, okay? Right, you just want to show the detail of a certain part, right, which would otherwise would be hashed, okay? You'd find this in most cases when we're looking at shafts. Right, okay, you have got a shaft. Right, let me just show it like this. Right, like that, okay? Right, but on the shaft, we want to insert, say, a key. Right? Or a pin, something like this. Right, and this one is a pin. Right, we know that a shaft is normally not hedged, but we want to scrape, right? In order to expose the key, which is passing through the what? The shaft. So this is what we refer to as part section, or it can also be referred to as scrape section, like that, right? So as long as there is detail inside a component that would not be hedged normally, you find that you need to expose that detail, okay, by scraping it or by exposing it so that you are able to show the detail, which is what we refer to as part section, okay? Right, so you would find on a shaft, on a nut, on all other parts which normally would not be etched, right? But if there is any particular detail that you want to expose, you would scrape it, you would show it as a part section like that. So that one is a part section, right? Name the type of section at J, right? We have got J, right? In terms of our, right, where is our J? Right, the type of section at right. You would find that that is critical, right, in terms of looking at all that, okay? Right, here we have got a cutting plane and a resultant section. We have got a cutting plane and a resultant what? Section, a cutting plane and a resultant section. Right. These, they form sort of a pattern, okay? You want to show the size here, you want to show the size, and in most cases, when it is on the side, right, it is referred to as removed section. But because they are a C like that, right, and they are in line like that, this is a typical example of what we refer to as successive sections, okay? Right, you want to show the different sizes, right, but at the same time illustrating the different nature in terms of the component at different parts and so, right, so this is right, successive right, like that. Right. That is successive sections. Right, with the reference to tolerance, right, at K, right, determine the minimum dimension. Right, let's go to K, right? So you look for the keyword. The keyword there is K, right? Remember, sometimes you take time to notice the keyword J. So you look for J for this particular question. So that's at different positions, right? So you look for the keyword. Look, if it says J, go and identify that J. If they say at K, go and identify first of all K, and look now, relate to what is being asked, right? They are talking about tolerance. Right, in engineering drawing, right, there is this issue of tolerance, okay? Right, you'd find that you talk about the allowable tolerance, right? Allowable tolerance, right? Normally you'd find that that is the highest or the lowest which can be in terms of size. Right, so sometimes you find that it is plus or minus 0.8. That's plus 0 is minimum. You subtract minus 0.05. So given the size, say the size is 20, right? If it is maximum, you'd find that you would need to say 20 plus 0.05, which would give you 20.05. If it is minimum, you would find that you need to say 20 minus 0.05. 20 minus 0.5, which would give you 19, which is equal to 19.95, like that. So the minimum, you cannot go beyond this in terms of what? The exercise. That can be allowed or is that. Then you have got that can be accepted is that. That would give us what we refer to as tolerance zone from 0, 20, 5. Right. If they say a minimum is subtracting. So what is it we are subtracting? We are subtracting this one, which is 0. We get a value. So say 3 minus 0.1. Right. We now get 22.9. That is the answer that we require. Right. If they had said they want the maximum, okay? For maximum, you were going to say 3 plus, right? 0.15, which would give you 3.15. All right. So the difference between that and that would give you a range in terms of the tolerance range. So you cannot go beyond, in terms of the reduced size, 2.9. You cannot go beyond 3.15 in terms of the maximum size. That's what tolerance is all about. Okay. So minimum you subtract with the lowest, right, the lower part, then the maximum you add with the upper part as well. Right, it could be 0.15 plus or minus. So you would play around. If it is maximum, you add 0.15. It is minimum, you subtract 0.15. Then you get your answer. Okay, that is about tolerance. So when we look at this one, check also, right? Check with regards to this one, there are 2 marks there. Right, what it means is that you need to say 3 minus 0.1 is equal to, like we said, it's 2.9. If there are 2 marks for this particular question like this, you need to show calculation. So 1 mark would be for the calculation and the other one would be for the answer itself. Right? Then in the space below, draw in neat freehand the symbol for the projection system used. Right, so if we take this one up, right, you'd find that there is a center line there. Let me just highlight this. Right, this would you never know. What is that angle orthographic projection? We don't use first angle orthographic projection. So if you are given a center line like that, right, first of all, define that. Then you have got these 2 lines, right? Before you define the center line in terms of that vertical center line, you would draw like this, right? Then you take this one there to the first line. Then you would draw again another circle like that. Then you would project like that. Connect this one to there, you connect this one to there, then you outline this. Right, okay. Then you can also now show the center line, right? So in terms of marking, right, that projection symbol, right, here there's a center line, normally it is given. You would find that they would look at this, at that, right, which is 1, 2, 3, 4, 5, 6, 7. The other one is for freehand. Okay, so drawing everything using freehand. That's how you would end up getting 3, 4, 5, 6, 7, 8. Right? I need you to make sure that whatever you do, get to understand how to draw this projection symbol, right? Which is the analytical. Remember, the moment you face this direction, right, it is totally wrong. The moment you draw these ones here, right, you are marked wrong. Right, they just want to check whether you are able to understand and represent this projection symbol. Third angle orthographic projection, what you see from the left is drawn on the left, what you see from the right is drawn on the what? On the right. So this one basically is our left view and this one is our front view. But at the same time, you would find that we can also talk about this being the front and this being the right view. Let's get to it. I'm going to sketch the first thing. So faintly like this. Create 2 lines like that. to project this, project that, then another one, project center line, then there's a center line. Right, remember this one would be given, right? Like I said, right, you have got 1, 2, 3, 4, 5, 6, 7, and the 8th one is to draw this using what? Using freehand. This one will be given in terms of the center line. So you need to make sure that in terms of paper 2, the analytical, right? You do it in about 20 or so minutes, okay? So that you devote much of your time to other demanding questions, okay? Right. So that's how we look at analytical, but I thought we would do exercises. One is fine, the assembly drawing. Remember, analytical is linked to assembly drawing as well. Most of the things that you would find here, they relate to assembly, okay? Right, so this is the theoretical part of it. We are going to look at the practical part with regards to putting everything together, right, which we refer to as analytical drawing, okay? Right, so boys and girls, I hope you understood and you appreciated what we did today with regards to completion of an analytical question. Thank you. Good night.